Hello. Uh, we learned how to calculate the conditional probability. In this video, I'm going to consider a more realistic example and real data with the real data. So the data I'm going to show you is from the National Health Interview Survey called NHIS data in 2018. So it's updated every year. So actually, you can find more recent data, but I'm lazy, and I'll show you. It has this type of data. I collected only two variables. The first variable is uh, the question. The first question is ever prescribed for high cholesterol, and the second one is have you ever smoked? So, and answers are of course yes and no. The answers are possible answers are yes or no. So, answers to those two questions are recorded. I collected, I cleaned up the data and only isolated these two variables. And we are going to define S for the smoked and H for the prescribed medicine for high cholesterol. So so this yes for the second question, H is yes for the first question. And remember, we would like to do this, answer this question. The original question is, does smoking increase the risk of high cholesterol or not? So smoking increases the high cholesterol risk or not? Then, to answer that question, what kind of probabilities do you need to compare? So remember, the event comes after the bar is the condition. So this probability should be interpreted as probability of smoking given high cholesterol. And superscript C is the complement. So think about this, and it's a really, really important question. So you should answer this. Answer this. Three, two, one. The correct answer is this. You should compare these two. So the first one is the probability of high cholesterol if smoked. Uh, 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 and second one is the probability of high cholesterol if not. So it compares occurs. So two groups are those who smoked, those who have not, and we compare these two groups of for their probability of high cholesterol. So this is what we have to compare. Now I am going to calculate these probabilities on Excel. So on Excel, I have a lot of just yes, yes, and no's. And if you go down, the last one is 7,889. So there are 7,888 observations, right? And remember, to calculate the probability, we used pivot table. So pivot table is what we use, a very useful function. So click, click, click. So we have these two, and you can make columns defined by smoking and rows defined by cholesterol. So you may change them, does not matter, and drag anything to value. So in the value here, it doesn't matter whatever you use here. And then it shows frequency distribution table, right? Say not like 1190 individuals, people have not smoked at all and have not uh, been prescribed for high cholesterol. This is smoking and cholesterol. So no cholesterol, no smoking, and uh, no smoking but cholesterol, and smoking and high cholesterol. So that way. and we obtain probability distribution table by, look at this. So click here. I'm going to, so click this drag down button and value field settings and change show value as percentage. Then we obtain the probability distribution table, right? Probability distribution table, of course, the summation of all four outcomes will be 100%. And let's have a look. So the probability of no smoking is 52%, and 47%, more than 47% of people have smoked before, right? And surprisingly, more than 75% of people have been prescribed for high cholesterol. So it's this is the probability marginal distributions and joint distribution here. But what we want is, as I said, you cannot compare across different groups, across variables. Therefore, we need to change those probabilities to conditional probabilities. We can do that by going back to this option. By this setting, go to the setting here, and now click here. Instead of percentage of grand total, I'm going to uh, calculate percentage of row total. Think about this. Then what it calculates is, so it calculates percentage, so sum of each row is 100% always. So that means out of no smoking, it's no smoking. So row is smoking. So out of no smoking, 28% had no cholesterol, but 71% had cholesterol, right? And then, so this is one complete probability because they make 100%. And another row make another complete probability distribution. So among those who have smoked before, 80% had high cholesterol, right? So now you can compare these two probabilities. The point here is we can calculate the conditional probability by changing this. If you change it from row total to column total, it will change the condition. Now, this makes one probability distribution, and this makes another. So that is, among those who have not been prescribed for high cholesterol, 61% did not smoke, have not smoked at all, and 38% have smoked before. So the condition and the main event is switched by changing the column and row. So this is how we calculate the conditional probability on Excel. It it is very useful, as you see, and uh, I'm not going to show you everything on these options, but you may try different things just to see what happens, and you can learn by yourself by trying different things from different data. So that's yours. Try and go back to the slides. So we calculated, we made a probability distribution table, and then we learned how to calculate conditional probabilities on Excel using pivot table. So now do it by hand, or you can. I will now connect the results to the probability distribution table. How can we calculate conditional probability from the probability distribution table? There is no difference. So in the previous example, we assumed, we considered frequency distribution table. So the frequencies are easier to interpret. The frequencies are number of observations for each outcome, so it was easier to understand. But now, simply replace the frequency with probability. Still, the way to calculate the how you calculate the conditional probability is the same. Like first, delete the probabilities that do not satisfy the condition. So delete outcomes that do not satisfy the condition, and then calculate the ratio, the probability of high cholesterol, treating them as if they are frequencies. So just calculate as if they are frequencies, just in the same way, and you will get the conditional probability. So calculating by hand uh, is the same as like whether you have a frequency or a probability distribution table. Then as a formula, you can write it this way. Probability of A given B equals the ratio between probability of their intersection divided by probability of the condition. So identical. They resemble really the same. Actually, they are the same. In all the intuition the same. So I don't need to explain them again. Should be simple enough. And now then, I want you to try this. Determine the probability of high cholesterol among those who have not smoked at all. Do it by hand. You may use a calculator. Please do it. Do it. Uh, I'll give you 3 seconds. Pause the video. 3, 2, 1. The answer is 71%. So the idea is the same. We delete the first column. It does not satisfy the condition. The condition is S not happening, but it satisfies S. Delete them and calculate the ratio of H among these two outcomes. So simple. Now you can compare probability of high cholesterol if smoked and if not. By changing the condition, you can compare them, and it looks like smoking increases the risk of high cholesterol. So, but it's not a medical conclusion. It's just an example with the real data. So there are a lot of complicated theories and a lot of things to consider in here. But in the in assuming the simplest possible scenario, it looks like there is a clear difference. And okay, back to the formula. We defined conditional probability in this way. This formula is very useful and simple, and by simply moving this term to the other way, to the other side, move the denominator to the other side, then you get this. This is a very interesting formula. Probability of intersection equals probability of condition and times probability of the other event happens given that the condition happened. Right? So you may understand this formula in this way. A and probability of A intersection and B is like kind of simultaneous experiments. You try A and B at the same time. So try two coins, throw two, say A is a coin and B is a dice. And throw coin and dice at the same time. But alternatively, you may throw coin first, and if the outcome is what you are looking for, then throw the dice. So conditional on the first event, you are checking the second one. So sequential interpretation or sequential experiment, hypothetical experiment, but and simultaneous experiment is a way to understand the formula. This formula is called the general multiplication rule. So it's a multiplication rule because it expresses the probability of intersection as a multiplication. Okay, it's over 15 minutes, so I'm going to stop here and we'll continue directly from here.